And there goes our entire FX budget for the year. Welcome, Homelabbers and self-hosters. Rich here. If you caught our last video about the Zimaboard, you may have also caught wind about the possibility of using a 10 gig NIC in its exposed 4x PCIe slot. The idea sounded just crazy enough, we figured we'd give it a shot. The question is, will the Zimaboard be able to fully utilize the power of two 10 gig NIC connections, or will this little SBC finally meet its match? Well, let's find out. Alright friends, let's talk about NICs and connections. We'll be using this rather standard Intel X520DA2 2x10 gig NIC, which is fully supported in pfSense. The astute amongst you probably have noticed that this card is in fact an 8x PCIe card, and our little Zimaboard is only 4x. There's good and bad news here. The good news is this 8x card will happily work in the 4x slot on the Zimaboard. The bad news is it remains to be seen whether the 4x slot has enough bandwidth to run both 10 gig SFP Plus connections at full speed at the same time. And this is something we're gonna find out. Now clearly it's not safe just to plug the NIC directly into the side of the Zimaboard without something to mount it to. So our first stop here is to 3D print something that we can mount the Zimaboard and the 2x10 gig NIC to before we start testing. Thankfully, the internet is a big, beautiful place, and I found someone that's already done the hard work here. User Martin Rowan has created a simple and elegant solution for solving this problem with his Zimaboard wall mount for generic PCIe cards STL from printables.com. We've dropped a link in the description to his model in case you want to print one up yourself. Let's toss it into my slicer, spin it around a bit, yep, it's a model, slice it, send it to the printer, and get it printing. Alright, here it is all happily mounted on the 3D print, and the 10 gig SFP Plus NIC is secured and ready for us to get testing. On the left side of the screen is an Ubuntu Linux VM on the WAN side of the Zimaboard that will act as our iPerf3 server, and on the right is another Ubuntu Linux VM that's on the LAN side that will act as our client. To start the iPerf3 server, we'll enter iPerf3-S for server, and -V for verbose mode, and hit enter. Then on the right, we'll enter iPerf3-C for client mode and enter the IP address of the iPerf3 server on the other side of the firewall, -V for verbose output, and lastly, -T followed by 15 to have the test run for 15 seconds. Let's kick this off, and go! And these are pretty dismal results. Bidirectionally, our single stream only produced a maximum sustained throughput of 1.05 gigabits a second, which is much better than the wired connections already embedded on the Zimaboard. Whew, those results were really underwhelming. And I feel like there's something holding back the performance here because the PCIe 2.0 4x slot on the Zimaboard should be able to fully handle the full performance of this NIC. The PCI Express standards specify that a 2.0 4x port should sustain a maximum of 2 gigabytes a second, which is more than enough to handle my 2x10 gigabit card's throughput. So let's test this again using multiple parallel streams in iPerf3 to see if we get better results. Alright, here we go again. iPerf3 server on the left on the WAN side, all ready to go, and on the right, we'll type in iPerf3-C for client mode, and enter the IP address of the iPerf3 server on the other side of the firewall, -V for verbose mode, -T15 for 15-second run length, and new to this test, -P for parallel streams mode, and define 10 parallel streams to run. And go! Okay, that's much better. With 10 parallel streams running, we reached an aggregate bandwidth of 4.35 gigabits a second, which is way better than the first single stream run of only 1.05 gigabits a second. 4.35 gigabits is great, but it's a far cry from the 10 gigabit promised land we were hoping for. So what gives? I believe I know exactly what's going on here, and there's a simple test we can do to see where the bottleneck exists. Let's do it now. Sorry for the eye chart here. On the left is our iPerf3 server, in the middle is our iPerf3 client, and on the right is an SSH connection into our Zimaboard SBC running top, showing us the real-time processes and utilization of pfSense. What we're planning to do here is see if the 4.35 gigabit bottleneck is CPU related or not, cause I think it is. Anyway, iPerf3 server is already running on the left, so in the middle on our iPerf3 client, we'll type in iPerf3-C for client, followed by, you guessed it, the IP address of our iPerf3 server, then -V for verbose mode, followed by -T300 for the test run length of 300 seconds or 5 minutes. And finally, -P10 for 10 parallel streams of sweet iPerf throughput testing. Let's hit the go button. And we can instantly see our problem right there. If you look on the right at the CPU section, you can see out of the 4 cores we have, 3 of them are pinned at 100% CPU utilization, showing us beyond a shadow of a doubt that while this little ZIMABOard can do some pretty incredible things, it doesn't have the power to run 10 gig networking due to the performance limitations of its CPU. And hey, this isn't a bad thing, it's a Celeron after all. Cut it some slack. One more thing to add. Some of you might be wondering why a single stream performed as poorly as it did, running at only 1.04 gigabits when we can get over 4 gigabits with parallel streams. What gives? And the answer is simply this. pfSense processes single data streams single-threaded. So when I ran a single iPerf3 test, 1.04 gigs was the most I could push through a single core of the CPU. I learned this lesson the hard way back when I built my own hardware firewall because I wasn't seeing the throughput that I expected, and after further testing, found that to be the answer. By the way, you should check out that video if you're big into pfSense and you're looking to build your own hardware firewall. And that, friends, will do it for this video. If there's something you'd love to see us test with the Zimaboard, or you have a beef with something we did, get down those comments and let us know. And now that you've finished watching this video, how about checking out some of our other great Homelab videos we've done in the past?